Okay, so then in this video, we're going to continue to go with slope fields, but instead of doing them manually, what we're going to do is we're going to use my graphing calculator program, which you can also buy, or you can maybe find its equivalent. It's a pretty nifty thing. And this is just how they want to do it. So this is kind of, I just have to make it how they want to do it. Times cosine y squared. Okay, so this is the way that you got to read this is dy dx equals sine x times cosine y squared. And so when I do that, I get this nifty thing like that. And so now this is, so there's my slope field, and so you can sort of see that if I sort of come in like that, it kind of goes up, and then it kind of goes down, and then it kind of goes up. It's kind of hard to see exactly what should happen, but I think, but then this is a separable differential equation, so you guys should be able to know how to handle a separable differential equation. And what I come up with is I come up with tan y equals negative cosine x plus c. And let's make that a little bit more contrasting there. And so you see there's one solution for c equals 1. I'm going to actually change this to n minus 5. And then it's going to give me a little slider down here. And so this is 0 minus 5. So that blue is negative 5. C equals negative 5. But then as I sort of increase, I go like that. So there's C equals 5. There's C equals negative 5. And it sort of goes like this. So I get different solutions based on my value of C. And so here I've got one where I'm kind of going, where you can sort of see that it's following the slope fields in general. So there's one example for you. And then next one, well, I might as well just change it around. Let's do this one. Let's take this out. Let's do x minus y. Okay, and let's zoom in a little bit. That's what I want to see right there. Okay, so now this is dy dx equals x minus y. So where x is 0 and y is 0, it's equal to 0. Where x is 0 and y is 1, it's negative 1. Where x is 1 and y is 0, it's 1. And you can sort of see 2 and 1. 2 minus 1 gives you a slope of 1. So there's your functions like that. Okay, so then if now this is a first order linear differential equation, so I will be doing how to solve these in the future. I've already, in my introductory one, I gave you the solution to that, so you should be able to stop this and figure out how to do dy dx equals x minus y. Rearrange that to be dy dx plus y equals x, and then you should be able to solve that. And if you did it properly, which is, you should be able to get this. That you should be able to go, oh, I'm sorry, e to the x. I made that mistake previously. There you go. So, and then again, that's c equals 1, so I can also just change it around to make that again n minus 5 so I can get my little slider on the bottom. And so when n equals negative 5, I've got that. And then right around where n equals 0 is going to be somewhere like that. And then n equals positive 5 is going to be like that. So you can see here that it follows the slope down. The slope gets less and less and less. The slope goes horizontal right there. And then it goes up, 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 up. And then over here, it again just sort of follows the slope fields like that. Okay, so once again, you've got a c in there, which determines which specific line you take. And there's your general solution is y equals x minus 1 plus c over e to the x. And then, you know, if I just sort of plug in x equals 0, and that's sort of, well, then c gives you your specific solution. That's all I want to say on that. And so there's more on slope fields.